Good evening. Welcome to
MathForKids number 112.
112.
Happy Pi Day!
Happy Pi Day. It's Pi Day today, which means it is March 14th, which is 3/14. And pi, do you know what pi is?
Yeah, it's the first three digits are 3.14.
Right, the first three digits are 3.14 equals pi. And do you know what pi is?
No.
No? Pi is a really special number. It's equal to the ratio. If you take a circle and take how long it is to go around it,
Yeah.
that's called the circumference, over how long it is across the circle.
Diameter.
Okay, and that's called pi. So it's just some number. It's a ratio, like 3/2 or 91, 27ths or something like that. It's just some ratio. However, but for every circle, it's the same. How long you go around the circle and how far you go across it is the same. And there's some really neat stuff about pi, and people kind of like pi and they like to study pi, and people have studied it for thousands of years. In fact, one of the first people to say some neat stuff about it, although a lot of people in ancient times knew about pi, people in Japan and China and Mesopotamia and in Greece, one of the people who knew a lot about pi was Archimedes. How do you spell Archimedes? A-R-C-H. I think so, Archimedes. And this is about the 3rd century BC. So that's more than 2,000 years ago.
Wowzy.
Wowzy. He figured out that the fraction 3 and 10/71 was less than pi, but pi was less than 3 and 1/7. That's pretty good. He didn't have computers or calculators or even an iPad. I wonder what did he do? What did he do? And by the way, this is about 3.14. What is it? 3.14084. Less than pi is less than. Do you remember what 1/7 is?
Yeah, it's the 3.14287 thingy.
Yeah. Okay. That's what Archimedes figured out. And people maybe got a little bit better than that, although oddly enough, not that much better than that. And then until somebody figured out kind of a crazy formula for pi in about 1655. And his name was John Wallis. This was about 1655. He figured out a really neat formula, not for pi, but for pi over 2. And once you know what pi over 2 is, how do you get pi?
You multiply by 2.
You multiply by 2. So he figured out this amazing formula. Pi was 2 over 1 times 2 over 3 times 4/3 times 4/5 times 6/5 times 6/7 times 8/7 times 8/9 dot 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 dot. So if you multiply all these fractions together,
You're going for infinity.
it goes on for infinity. Incredibly, you get pi over 2. Can you believe that?
Wowza.
And then, what is this guy's name? Broder? I might have that name wrong. In about the same time, figured out that this formula was equivalent to, this is kind of some of the neat things that math people do. They figure out, oh, this is the same thing as saying that 4 over pi equals the continued fraction 1 plus 1 over 2 plus 3 squared over, a lot of people write this as 1 squared, 3 squared, 2 plus 5 squared over 2 plus
look.
7 squared.
Those are odd numbers.
Yeah, so pi somehow relates to the squares of odd numbers in this funny continued fraction way. So you have these two crazy formulas. So a lot of times you'll hear people say about pi, there's no pattern for pi. But they figured out formulas that have patterns for them. This continued fraction, 1 plus 1 over 2 plus 3 squared over 2 plus 5 squared over 2 plus 7 squared, dot, 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 dot. That's pretty neat, right?
Yeah.
Yeah, and then after this, actually not that long after this, a subject called calculus was discovered by Newton, who's English, and Leibniz, who was a German, and they figured out another formula for pi over 4. It may not be attributed to them, but they discovered calculus. It's 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9. Well, I shouldn't say plus. You just keep alternating minus and plus. Plus, minus, plus, minus, plus. So I guess this would be a minus. Minus 1/11. Then you just go on forever. So this was an incredible formula for calculating pi. Now here you don't get pi, you get pi over 4. So once you're finished summing this up, what should you do?
Multiply by 4.
Multiply by 4, then you're going to get pi. So this is just, again, the odd integers. Isn't that amazing?
Mm-hmm.
And this is probably 1665. But that's a long time ago. You know how long ago that is? It's almost 400 years ago. I guess it's 350 years ago.
Wow.
Pretty long time ago. Then, there was a mathematician named Euler in the middle of the 1700s, 1748. And he found another amazing formula for pi. Well, this time not pi, but pi squared. You ready for this?
Yeah.
Pi squared. Well, actually, let me show you something else first. You know that 1 plus 2 plus 3 plus 4 plus 5 plus... Just adding up the integers, what are you going to get when you add those all up?
To infinity?
Yeah. Do you get infinity or do you get beyond? Do you go to infinity or beyond?
It's infinity.
Infinity. Okay. Now, incredibly, when you add up the reciprocals, 1 plus a half, plus a third, plus a fourth, plus a fifth, you know what this adds up to?
It's going to add up to 1 over infinity?
Oh, good guess. But actually it gets bigger. This actually gets bigger and bigger. It's hard to understand because the numbers go to 0. They get closer and closer to 0. But this also adds up to infinity. Wow, that's pretty amazing. We'll talk about this someday. But actually this isn't too hard to understand, but you need to know a little bit about fractions. And Euler in 1748 or in the middle of the 1700s, something like that, added up the inverse squares. 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared. And you know what that adds up to?
What?
Pi squared over 6.
Whoa.
Pi squared over 6. So the sum of the inverse squares, so this is 1 over 1 plus 1/4 plus 1/9 plus 1/16 plus 1/25 plus 1/36 all the way up. That adds up to pi squared over 6.
Wowzy,
Can you believe that?
yowzy.
Pi squared over 6. How did he figure that out? In 1748. They didn't even have iPads then.
I don't think they even had computers.
No, they didn't have computers. Maybe he saw it on television. Maybe. Alright, so last thing I want to show you about pi. This is also in the 1700s. And this is an interesting guy named Buffon. This is like 1777 or something like that. He came up with a probability game. And he said if you take rulers and mark off lines like this, and they're all supposed to be equally spaced. So that these are all supposed to be the same distance in between. I just didn't draw it super well.
Yeah.
Okay. Can I have your orange marker for a second?
Okay.
Now you take a needle that's exactly as long as this. Okay, as long as the distance in between the lines. And you just start throwing it onto your paper that has these lines on it. So sometimes your needle lands like this, sometimes it lands like this, sometimes it lands over here, sometimes it lands over here. Sometimes it lands like that, or like that, or like that. Okay?
Fun game.
Fun game, yeah, you just keep throwing needles at this paper. But you know what happens? The probability, the number of times the needle crosses a line divided by the total number of throws. So if you do this lots and lots of times and you take the total number of times the needle crossed the line, once, twice, 3 times, divided by the total number of throws, 1, 2, 3, 4, 5, 6, 7, 8, in my example. But you have to do it lots of times, like thousands of times, thousands of times. This equals approximately 2 over pi.
Whoa.
Whoa, can you believe pi comes into this? What is this? Doesn't have anything to do with circles. This doesn't even have anything to do with numbers. It's just some straight lines and a needle, and you just keep throwing the needle again and again and again. Pretty amazing, right?
Yeah.
So that's all the really neat stuff about pi. And people love to learn about pi. One thing people like to do is they like to memorize pi into as many digits as they can. Think you'd like to do that someday?
Maybe.
You know how many digits it has?
Infinity.
Infinitely many. It's like, I don't know too many of them though, but it's 3.1415926535897793. Keeps going on like that. So people like to try to remember as many digits as they can. It's actually kind of a fun game to test your memory.
Yeah.
Alright, so there you go. So that's Pi Day. So I guess tomorrow we'll go back to making movies about Pascal's triangle, right?
Yep.
Alright, was that fun?
Yep.